Hi everyone, Ms. Caulfield here. We are going to be continuing looking at how to make measurements properly on different pieces of equipment you'll encounter in your chemistry class this year. So looking at what's on the screen right now, the first thing we're going to be practicing is making measurements on thermometers. So when you're making a measurement on any piece of equipment, the first thing you want to do is figure out what that piece of equipment counts by. So what does all of the little graduations or markings on the piece of equipment represent? So when we look at this thermometer on the far left, this is going to be the one we're starting with here, we see that there's a marking for 30 and that there's a marking for 40, and in between those markings there are 10 different graduation marks. So we would say that this thermometer counts by ones. And if it counts by ones, it means we're going to have to measure one beyond what we can see. So when I take a look at the height of the alcohol in the thermometer, I see that I am certain that I have at least 32 degrees Celsius in this thermometer. I can see the 32 dash line, and I can see that the thermometer reading is a little bit above that 32 marking. So now I have to go ahead and I need to estimate what value is between the 32 marking and the 33 marking, and my estimated digit here is going to be about 3. So we have about 32.3 degrees Celsius in this thermometer. Looking at our thermometer to the right of this one, now in the middle, we see that this thermometer counts by 0.1. And we see that because we can see the 21 reading and the 20 reading, and there's 10 graduation marks in between. So when I look at this, I'm certain that I have at least 20.2 degrees Celsius because I can see that I am a little bit above the 20.2 degrees Celsius, and now I need to add in my estimated digit. So we'll say maybe 20.22 degrees Celsius for the reading on this thermometer. Remember, for your estimated digit, like the 3 or the 2 in these two measurements, your estimated digit can't be wrong because it's an estimation, so just do your best to make your reading. All right, and our last thermometer, the one on the far right, we are looking at the reading, and the difference between this thermometer and the other two is that the reading on this thermometer is going to be negative. So sometimes it can be tricky when we're looking at a thermometer and taking a negative reading. I would recommend, if you can, to go ahead and label the graduations because that's going to help you have a better idea of the reading you should make. So when we look at this thermometer, we see that the reading on the thermometer falls between -8 and -9. So we're going to go ahead and we see that this thermometer also counts by ones, like the first thermometer we looked at in the video. So we're going to go ahead and make our reading maybe -8.6 degrees Celsius. You could also write -8.5. That 6 is my estimated digit, and so your estimated digit might be a little different, and that's okay. So another piece of equipment that you could encounter in your chemistry class is a graduated cylinder. When we're making measurements on graduated cylinders, we see that the level of the liquid in the graduated cylinder actually forms this caved in shape, this curve within the graduated cylinder. This curve is what we call the meniscus. And when you take your reading for graduated cylinders and also in burettes, which we'll look at next, you're always going to take your reading at the bottom of the meniscus, not the top. We're going to be taking it at the bottom. So the steps for making your measurements are the exact same. We're going to take a look at the measurement, or I'm sorry, the graduated cylinder on the far left first. We see that this one counts by 0.1s, and I am certain that I have at least 8.7 milliliters of water in this graduated cylinder. And now I need to estimate how much more than 8.7 I have, and I'm going to go ahead and use 0.04 as my estimated digit. So I'm going to say that that reading is at about 8.74 milliliters. Looking at the graduated cylinder to the right of this one, we see that this one counts by ones. And I'm certain that I have 44 milliliters of water, and I need to include my estimated digit. And I'm going to go ahead and estimate that this is 44.3 milliliters of water. There are two other graduated cylinders over here on the right-hand side of the screen. If you'd like to do some extra practice, you're more than welcome to do that. So the chances that you've used thermometers and graduated cylinders in your other science classes is pretty high. One piece of equipment that might be new to you is a piece of equipment called a burette. So burettes also are used to measure volume, but burettes are used when the amount of liquid needed is unknown. So when you use a burette, you're going to end up taking two measurements. You're going to be taking an initial measurement and a final measurement because what we really are measuring is the amount of liquid that is dispensed or released from the burette. Similar to the graduated cylinder, we see on our burettes that there is a meniscus that's going to form. I can show it on both. And you're going to be taking your reading at the bottom of the meniscus. When you go to make your measurement, it's going to be the exact same process as it has been on the other pieces of equipment. You want to first figure out what the instrument counts by. So this instrument counts by 0.1. And so when you take your measurement, you want to estimate one beyond what you can see, which is why the measurement is recorded to the hundredths place. And it's the same with the burette on the right-hand side of the screen. So the last thing that we're going to look at in this video is comparing graduated cylinders versus burettes. So the first difference that we're going to just look at one more time is what they are used for. So like we mentioned on the last slide, so burettes are used when the amount of liquid needed is unknown, and the grad cylinder is used when measuring a known amount of liquid. So an example of that would be if we're in class and I give you a lab piece of paper, a lab sheet, and in the procedure it says, please measure out 15 milliliters of water. You know how much water you need. You know you need 15 milliliters of it. So in that situation, you would go ahead and grab a graduated cylinder. An example of when you would use a burette is when you're trying to answer the question, how much sodium hydroxide is needed to neutralize acetic acid. And so when you're trying to figure out how much of a liquid you need, that's when you're going to end up using a burette. Burettes are often used in what is called titrations, and we'll be learning all about titrations later in the year. The other thing to notice about graduated cylinders versus burettes is the numbering on them is opposite. So on the graduated cylinder, messing myself up. Here we go. On the graduated cylinder, your higher numbers are going to be at the top and your lower numbers are going to be at the bottom, or your lower readings. So they're going to increase going up. Whereas on a burette, your lower numbers are going to be at the top and the higher numbers are going to be at the bottom. And they're going to increase going down. Again, remember this is because the burette takes two measurements and you're going to end up doing final minus initial. To figure out how much of the liquid was dispensed. The last thing we're going to be looking at here is answering this question, which is more precise. So to determine when you're looking at two pieces of equipment, which one is more precise, you want to figure out how many significant figures you can report for each instrument. So if we look at the graduated cylinder, we see that this graduated cylinder counts by ones, whereas the burette counts by 0.1s. So when I make a reading on the graduated cylinder, I can record all the way to the tenths place. So this looks like it could be about 25.3 milliliters of liquid in the burette. When I take a look at my graduated cylinder, I can see that I have about 25.3 milliliters of water in the burette. So because I can report to more decimal places in this burette, we would say that the burette is more precise because it can report more significant figures. It is possible for us to have graduated cylinders that also count by 0.1 versus 1. And so in that situation, if we had that grad cylinder in this image and we're comparing it to the burette, the precision of those two instruments would be the same. That's it for today.